Okay, today we have something a little bit out of the ordinary for me. This is a 2 Tesla coil setup, still involving radio systems, but this one's a little different. Today we're going to look at power transfer between 2 Tesla coils. This is a little bit different from what most experiments I've seen have done, since most experiments simply create sparks, create music, create other things, but very few have actually attempted to recreate this experiment by Nikola Tesla, showing how power transfer works between 2 coils. Now, this will essentially work at any distance as long as the system is high enough voltage and tuned properly. The system will transfer power. Essentially, Tesla coils work like 2 pumps. Let's say this pump on the right here, this red one, is a water pump, and it's connected through a tube. This tube here that goes around the bottom connects to another water pump. Well, of course, when we push and pull water using this first red pump, the water is going to push and pull through this tube, and it'll affect the second pump. Now, Tesla coils work exactly like that, except they're electrical pumps, not water pumps. So essentially here we have, again, our 2 coils. Secondaries are connected through a ground wire. That's the only connection between these 2 coils, is a single wire. The primaries are connected to capacitors, 2 air capacitors, which have been swiped out of some old radios. And then we have our circuitry. The circuitry here, as you can see, if it wasn't for these wires, is a PNP transistor along with a resistor and a diode. That's essentially all there is. That is connected to an oscilloscope / signal generator, which will be generating a square wave at 1.07 megahertz. This is how these Tesla coils are tuned. It's how it's based on the wiring, the winding of the secondaries and the primaries, which determines the frequency of the coils. And so, for example, bigger coils will have a lower frequency, smaller coils will have a higher frequency, but they all work essentially the same. And this is the basis for all radio systems, all systems that work over the airwaves as well, that Tesla invented. So let's get started here. Let's hook up our signal generator and see what happens. Okay, now that we have a nice tight connection there, we can see we're generating a sine wave on the secondary coil at about 5 volts. At the signal measured by the oscilloscope is 1.07, 1.06 megahertz, and the generated signal is about the same, 1.07 megahertz. Here's our LEDs. You can see the first LED is lit up quite bright. The second LED is just connected to this primary of the coil. There's no capacitor because this tuning capacitor tunes both primaries at once, essentially. Our oscilloscope here is connected to this gray wire, which comes down, loops up a bit, goes around, and connects to the tank circuit of our black coil. Now, the signal generator is the black wire. It comes around, goes around the battery, and connects to our circuitry, which drives this first coil. Now, what we can do to demonstrate how the system works a bit is show our LEDs and our capacitors, and I'll tune this one out of tune a bit. You can see the LEDs, the lights go out. Now we bring her back into tune, and they come on fairly bright. We can look at our oscilloscope here to see our voltage as we tune it. We should be able to get her up above, a little bit above 6 volts here. 6.31. As we bring it out of tune, it drops down to 4 to 3. Bring it back in tune. We'll get her up to about 6.3, 6.4 volts, somewhere around there. And as you can see, our LEDs are bright, drawing current. Not just radio power, but this is actual current. We're running off a 1.5 volt battery, powering 2 3.3 volt LEDs at whatever current it needs to light them up this brightly. That is basically the system. It works. It worked great. Now, the only hang-up of the system is that you need to bring the entire system into resonance. That means both these coils are working at 1.07 megahertz. If we were to connect this to the earth, in order to bring resonance up the same way, we need to bring the entire earth into resonance. That means you need a fairly big and fairly precise coil to make it all happen. This was the focus of Tesla's Wardenclyffe project, and this was how it was supposed to work. Transferring usable power through a single conductor, which can be the earth, which can be a wire, which can be just about anything conductive.